I want to give you some examples of how we name compounds, both ionic compounds and covalent compounds. So for ionic compounds, we need to make sure we're looking at how many of each ion there are based on needing to balance out the charge. So if I give you a compound like CaCO3, this one's actually really easy because calcium is just Ca. Ca is just calcium, So it's calcium, and then this, if you have looked at your chart on polyatomic ions and memorized the names of them, you know is carbonate. It's the carbonate ion. So it's just calcium carbonate. If we have NaCH2H3O2, you should recognize this part as the polyatomic ion acetate, and you should recognize this as sodium. And so in order to name this, you would just say sodium acetate. And you're done. That's really that simple. Now if you're naming a compound or creating a compound based on a name using a transition metal, because remember the transition metals have variable charges, like copper 1 oxide, well that means that copper, Cu, has a +1 charge. We know that oxygen has a 2 negative charge, so that means if we're going to make this look right together, we need to have 2 coppers for every 1 oxygen. Copper 1 oxide, because copper has a +1 charge, oxygen has a -2 charge. If we were going backwards, say I told you I had CuO, and you were supposed to name it. Well, you know that Cu is just copper, so that part's easy, but you also know copper is a transition metal. So you're going to leave parentheses there in order to figure out the charge. You know oxygen just becomes oxide because we just turn the end of the word into "ide." And you need to figure out if it's copper 1 or copper 2. Well, if we separate out these two ions, oxygen has a 2 negative charge. So if there's only 1 copper in the compound, that means copper has to have a +2 charge in order for the charges to balance out. So that means this is copper 2 oxide. If we're naming something like magnesium bromide, or not naming it, if we're having to write what the compound is. If I give you the name magnesium bromide, you should know that magnesium is Mg and bromine is Br. Magnesium is in group 2, so it has a 2+ charge. Bromine is in group 7, so it has a -1 charge, which means that in order to have the +2 on this side balance out the -1 on this side, we're going to have to multiply this side times 2 to get -2. So that means the compound is going to look like MgBr2. Naming and writing covalent compounds is really easy, but the thing you need to remember is that with a covalent compound you have to use prefixes. So covalent compounds use prefixes. So if I give you the compound I2O5 and I say please name it, you need to recognize this is a covalent compound. It is not an ionic compound, it's a covalent compound. And the reason it's a covalent compound is because this is a nonmetal and a nonmetal, and covalent compounds are compounds with nonmetal. Both elements are nonmetals. So we have to use prefixes to designate how many of each thing there are. So it would be diiodine, because there's 2 iodines, pentoxide. Diiodine pentoxide. Pent for the 5, di for the 2. So that's it for covalent. Let's write the formulas for these 2 compounds. If we have carbon dioxide, it's just simply C for carbon. There are 2 oxygens, so O for the oxygen, and 2 right here to designate the 2, and we're done. It's just that easy. Diboron tetrachloride means we have boron, which is B. We have 2 boron atoms. Tetra means 4, and we have chloride, So Cl for the chloride, 4 of those, diboron tetrachloride, and we're done.